a lot of tutorial and some of the examples. Here you first install your package Keras, and you load the Keras, and you have to install this again, and then R will restart, and then you're going to load the library Keras and some other packages. And what I want to show you, and not MNIST data, because we're getting so tired with this 10 class digits data. So I'm going to do the fashion MNIST. It's a built-in data set and in Keras. So you call this fashion MNIST, and this symbol is basically this means double assignment, because this data set actually the training test get two lists. One is the X, another is the Y. So we'll assign them as train-images, train.and labels. And you do the same to grab the test. So you can see we have 60,000 images, and each one of them is a 28 by 28, matrix, right? Gray color. And so we have 60,000 training data labels. There are 60,000. You look and basically equally distributed over the 10 classes, 0 to 9. And we have 10,000 test images. And what are the 10 classes? They are like t-shirt, trouser, and some other fashion items. Here, this is a picture of those. Anchor boots, and dress, sandal, yeah. So what you're going to do is you do your pre-processing. Because the original image is 28 by 28, what's stored at every entry is actually a number, integer between 0 and 255. We're going to do some scaling. We divide it by 255. So every entry is between 0 and 1. And then you're going to start setting up your network architecture. And we're telling R we're going to do a fully connected network. First is just the input is going to be a 28 by 28 matrix. Then we're automatically going to reform it as a long vector, about 700 something, I think. And then we're going to have a first hidden layer with 128 hidden units, and the output is actually a 10 output, because we get a numerical outcome for the 10 classes, and we do some so-called softmax, meaning e to the power the numerical number, right? And you normalize it, you get 10 probabilities. So then I tell R, here's how we're going to compile or fit our model. The optimizer we use, just pick one of the ADA, whatever, begin with ADAs are being adaptive. And our loss function, we do sparse categorical cross entropy. And you're going to see another thing called categorical cross entropy. It basically is just like, what's our loss function for, I have more space here. What's our loss function for a multi-class classification problem? So you will have your you write your likelihood for PI and YI. Oops, sorry. So you're gonna write something like your it just basically is just sum of YIJ and PIJ, log PIJ. Let me explain the meaning of those and PIJ. So J is from 1 to 10, I is from 1 to 60,000, okay? Because the YIJ will be a vector of length 10. So for example, for the first observation, if you're in the first category, then Y11 going to be 1, or the Y12 and all the way to this going to be 0, right? So for Yij, only one entry. So for the ith observation, only one of the j value is going to be equal to 1, or the other going to be 0. And the Pij will be the probability for the ith observation. What is the probability of the ith observation is in the j's category, right? So this is called the cross entropy and loss function. Now the difference between because in our training data, our label are from 0 to 9. We didn't do the dummy coding, and the other way you can think about the 10 classes will be, for example, if y is equal to 5, I'm going to create a binary vector of length 10 only at the 5th position you are 1, right? So different way you can parameterize the multi-class outcome. Either is a vector of dimension 10 if there are 10 classes, or it's just a new integer taking value from 1 to 10 or 0 to 9 in this case, the equivalent, right? So if you do that one-dimensional integer coding, then you do sparse categorical cross-entropy. If you do your binary coding of length 10, you just do categorical cross-entropy. It's just subtle difference, okay? And so we just specify this, and we just look at a summary of our model. So our input layer 784 because that's 28 by 28. One hidden layer fully connected with 128 hidden units, and output is 10. And once we get the 10 outcome, we can just do our softmax to get the probability for the 10 classes, right? So this is our structure, and those you can see there's a number of parameters, a lot. And then you can just do your training. You basically provide training data, training label, and you're going to do your SGD every time you process 120 observations, and you have to loop through your whole data 5 times. So and then you're done, and then you can do your prediction. So let's take a look how you're going to run this. I told you before, if you want to use AWS, you first Google that Louis website, AWS. Oops, Louis AWS R. Okay, so you go to this website and you just basically pick any. I usually go with Ohio or Virginia, and then just. Let's do, for example, if I pick this one. And then you're going to pick an instance. If you want to use a GPU, you go to something start with P. And so P, let's see, P4, these are P. Wait. How come it's not available P4? It's only P. Did I do P3? Oh, sorry, I do P2-X large. So I think it's about like 20 cents per hour. And you just going to pick that one, and you have to. So you have to go to your set up your security group. You have to add. Those are actually written on the Louis website. So you have to add HTTP. So you can do your web version RStudio, and automatically the port is AD, and you're done. Okay. Of course, you have your credit card has to be linked with this. Okay, so I'm here right now, and then you're basically going to copy this number in a browser, and that browser will ask you to input a password and username, and the username is RStudio, and password is actually this number. Okay, so now I'm here now. Okay, so now because this one got GPU, so at the beginning, I actually install my Keras where the TensorFlow is equal to GPU, and then let's. I think I'm here, so I have already. Let me set up the model. So I'm going to do run, and then I'm going to do compile, summary, and then I'm going. This means I'm actually not going to run. I'm going to run this one with a mini batch. So I'm going to move down and run this with a mini batch. So the model will be running. What does that mean? So this will show you the loss and the metric. I think I use misclassification rate as a metric. So it's done, and then you can evaluate. Then you can evaluate the the test data. Look at the test error, right? So you're gonna do your oops, sorry. Wait. So the test error. Oh, this is awful. Something must be wrong. Let me do the other. No batch. See what happens. So no batch is going a little bit slower. Well, I mean, no batch means the batch size basically is 1. Every time you only process 1 data point. Okay, so let's see. Okay, and then let's try score. Oh, wait, what happened? No, something. Oh, maybe I didn't normal. Okay, I know the problem. I haven't normalized the data yet. I only show you those plot, but I should normalize. I have to scale them, like divided by 255, right? And then okay, and then let me do the batch version because it's faster. I can see the accuracy is higher. I mean, this is on the training data. And so let's look at the test data. Okay, so it's 87%. This is a multi-class classification problem, so it's pretty decent. And then I look at the label, and here's just help you to understand how you get the first image, test image, the highest probability as the last one, which is a 10th class. The label is actually 9 because it actually means 10 because the number is from 0 to 9. Although it's not digits, but still they sort of follow the Python framework, always start with 0. And we can also look at the confusion table, and you can see that, well, it seems like for class 0 means class 1. I'm just going to say 1 is confused with 7, right? And we can look at actually, you can see 4, well, actually just only this one, only the first one and the 7th category. So what are the first and 7th category? They're actually t-shirt and shirts. So it's reasonable they actually got confused. We can also look at the, I have some other code we can play, but maybe I should stop here, and you can look at some of the output from my Rcode page, but you can find more from the example page on this RStudio and Keras website. Okay, I'm actually wanted to show you the result for the movie review using Keras. But that actually, I haven't tried to tune them, but the error rate actually, the AUC is not as high as the bar we specified, because we want it to be like 96% or 94%, I forgot. 96%, yeah. So, and of course you also have to, you can try to train some of the, take some of the trained vocabulary size and fit into this neural net and see what happened. But I think just simple logistic regression can do the job already. Okay, good.